So the last thing we need to look at is exponent rules that have to do with division, okay? This is not going to be difficult. It's going to look similar to what we did when we multiplied. You can maybe even guess what the rule would be given what we know about multiplication of powers. But the first thing I want to talk about just briefly is how to raise a fraction to a power, okay? So 2/3 squared. Remember, when you square something, that's 2/3 times 2/3. So multiplying fractions, I multiply straight across. So 2 times 2 is 4, and 3 times 3 is 9. We may have even done this when we did squares and cubes, but I wanted to review it again. So 1/4 cubed, remember when you cube something, that's 1/4 times 1/4 times 1/4. You multiply all your numerators. 1 times 1 times 1 is 1. And you multiply all your denominators. 4 times 4 times 4 is 64. So when you raise a fraction to a power, you just rewrite it that many times and multiply. Okay? Now, let's look at dividing with the same base. This is important. Notice that the bases match. Okay? So I'm gonna do this by expansion first. So x to the 5th is x 5 times. X times itself 5 times. And x to the 3rd power is x times itself 3 times. So I've got a bunch of x's, but they're not all in one row like when I multiplied. Now they're over each other. They're dividing. So remember, anything divided by itself is 1, okay? So I can cancel this x. X over x is 1. I can cancel this x. X over x is 1. And I can cancel this x. X over x is 1. And I'm left with these two x's up here, and x times x is x squared. Now, look at where we started and look at our answer. X to the 5th divided by x cubed over x squared. Look at it, and think about it, okay? Now, let's do this one with 4s. 4 to the 6th power is 4 times itself. 1, 2, 3, 4, 5, 6 times. And 4 squared is 4 times itself twice, okay? Now, every 4 over 4 equals 1. So that cancels and becomes 1. That cancels and becomes 1. How many 4s am I left with? 4 of them, so this is 4 to the 4th. Now, look at the problem we started with. 4 to the 6th over 4 squared. Our answer was 4 to the 4th. What do we do with the exponents when we're dividing? When we're dividing powers with the same base, we do what? We subtract the exponents. When you're dividing powers with the same base, you subtract the exponents. So this is what this looks like. Y to the 12th divided by y to the 5th. Since I'm dividing the powers, I subtract the exponent. So I'm going to do 12 minus 5, which is 7, and I get y to the 7th. Okay, they have to have the same base. That's important, and the base does not change. So 5 to the 16th divided by 5 to the 4th, I would not want to write that out because 5 to the 16th would be a pain to do. So I'm just going to take the 16 and I'm going to subtract the 4, and I end up with 5 to the 12th. Notice the base does not change. You just subtract the exponents. All right, what if I've got numbers and variables combined? Well, this is going to be just like we did with multiplication. 20x to the 7th over 5x squared. I'm going to take the 20 over 5 by itself, and I'm going to take x to the 7th over x squared by itself. Well, 20 divided by 5 is 4, and then x to the 7th divided by x squared, I'm going to do 7 minus 2, and I'm going to get x to the 5th. Okay? Now, what if I've got more than one variable? Same thing. Y to the 11th, z to the 20th. We would not want to write that all out. Divided by y to the 9th, z to the 17th. Well, we're going to split that up. We're going to do y to the 11th over y to the 9th times z to the 20th over z to the 17th. So I'm going to subtract 11 and 9 because I'm multiplying powers with the same base. So that would be y squared. And then I'm going to subtract 20 minus 17 because those have the same base, and I'm going to get z cubed. Okay, so when you're dividing powers with the same base, you subtract the exponents and you keep the base. All right, so what if I have both in the same problem? What if I've got multiplication and division and they all have the same base? Well, you're going to use both rules. You're just going to use them one at a time. So remember, when you multiply powers, you add the exponents. And when you divide powers, you subtract the exponents. So we're going to do both at the same, or one at a time, basically, okay? So I'm going to look at x cubed times x to the fifth. That is multiplying two powers with the same base. So I'm going to add my 3 plus 5, and I'm going to get x to the eighth over x to the fourth. Okay, so that's my first step, is to do the multiplication. And then x to the eighth divided by x to the fourth. Now I'm going to subtract those exponents, and I'm going to say 8 minus 4, and I'm going to get x to the fourth. Okay, so if we were to expand that, if we were to write 3x's and 5x's over 4x's, and then we start canceling out, we would be left with x times x times x times x. So you can expand. You don't have to use the rule. Expansion will work. Okay, so y to the 7th times y to the 10th over y to the 5th. I'm going to do the top part first. That's multiplication with the same base that we did last week. So I'm going to do 7 plus 10, and I get y to the 17th over y to the 5th. Now I'm dividing with the same base, so I'm going to subtract my exponents. So 17 minus 5 is 12, and I get y to the 12th. So just take it one step at a time, and you got it. All right, do your practice problems, and I will see you very soon.